Hey guys, Mr. Hart here. We're going to give a try for comparative advantage. We got two make-believe countries here. We have Heldia, I heard it smells ya, and we've got Romano Town. Nobody loves Mr. Romano. In each country, what we can see is that Heldia can produce 10 chairs per hour or 5 shirts per hour. Well, Romanoton can produce 12 chairs per hour or 4 shirts per hour. Question 1, how many labor hours do they have? So we're gonna actually let's go 10 hours. That's not even a word. I'm gonna fix that right there. Little mistakes happen when you go to single take videos. So they have 10 hours. Let's figure out what that means for each of them. For Heldia, that means that if they have 10 hours to work with, they can produce 100 chairs max, 10 chairs per hour times 10 hours, or 50 shirts. Now these are ors, not ands. For Romanoton, they are looking at 120 chairs and 40 shirts. From this inputs to outputs conversions, we can clearly identify that Romanoton has an absolute advantage in the production of chairs. If they used all of their productive resources exclusively for making chairs, they could make more chairs than Heldia. Whereas Heldia has an absolute advantage in the production of shirts. They used all their productive resources, they're going to make more shirts. But just because Heldia can make more shirts, does that necessarily mean they are better at making shirts? And by better, I mean more efficient. We're not talking about the quality of shirts. We're assuming that the quality of the chairs and shirts are identical country to country. What we're talking about is who's better at it, meaning who uses fewer resources, who can do it more efficiently. And in order to understand that, we have to convert all of this into opportunity costs. And for Heldia, every time they produce a shirt, they will be giving up a chair. And every time they produce a chair, they'll be giving up a shirt. Can we figure out the ratio of this exchange? And the answer is yes. So how do you convert 100 to 50 into a simpler ratio? One chair, for every one chair that Heldia chooses to make, they're giving up half a shirt. And for every one shirt they produce, they're giving up 2 chairs. For Romanoton, one chair is equal to a third of a shirt. For those of you that aren't following, how do you convert 120 to 1? Well, you can either subtract 119, which does us no good, but you divide it by 120, and you keep the ratio by dividing 40 by 120, and you simplify 40 over 120 into 1/3. So one chair is equal to 1 shirt, while 1 shirt is equal to 3 chairs. Now we have the information because we've created a list of our opportunity costs. We can look and see who's more efficient at each. And as we do that, I know that it costs Heldia half a shirt to make a chair, but it costs Romanoton only a third of a shirt to make a chair. Now we know that not only does Romanoton have the absolute advantage, meaning they can produce more, but they also have a comparative advantage, meaning they are more efficient at the production of chairs. Whereas Heldia also has the absolute advantage in shirts, but also has the comparative advantage in shirts. Because for every shirt they make, they're only giving up 2 chairs, whereas Romanotin gives up 3 chairs for every shirt that they produce. Now that we've identified the comparative advantages, we can start to look at specialization and trade. If Heldia is to specialize in shirts, then they're going to take their 10 hours, which is all they have, and they're just going to produce what they're better at, which is shirts. I hope I got that right. Now that I'm thinking back, I may have made a mistake. I'm going to quickly review my explanation to make sure that I didn't make a mistake a second ago, as I'm not going to edit this. This is a one-take show. We identified that Heldia's shirts are cheaper. So Romanotin, they're giving up 3 chairs per shirt, too expensive. Okay, so we got that right. Absolute, comparative, fewer resources given up, more efficiency to get there. Now we're going to specialize. And when we specialize, Heldia is only going to do what they're better at, so they're going to make 50 shirts. Romanotin is going to specialize in what they're better at. They're only going to make chairs, and if they use all of their time resources for what they're better at, this is what we end up with. We end up with 50 shirts and 120 chairs. So what does that mean? Well, that's what we have. We have a country that has produced 50 shirts. Do they want all those 50 shirts? Well, maybe they're willing to give up some of those shirts in exchange for chairs, because you know what? Well, not all the world likes chairs, but I do. I like chairs. So I understand why some people would want fewer shirts and have some chairs. And vice versa, you know, chairs are great, but it's also nice to have some shirts. We're going to identify the range for the terms of trade. My question is, should we price in terms of shirts or chairs? Let me do a little quick look at the board to see. I like shirts, and you're going to find out why in a second. So we're going to find out what one shirt should cost in this exchange. Who made the shirts? Heldia did. How much did it cost them to make a shirt? Well, it cost them 2 chairs. Would they be willing to sell their shirt for less than what it cost them to make it? And the answer is no, because that would make them poorer. There's no incentive there. So we know that the lowest price that anybody would accept for a shirt being produced in Heldia is 2 chairs. So the price of a shirt has to be greater than or equal to 2 chairs. Romanotin is going to be buying these shirts, and they're going to be spending chairs. And for them, a shirt would cost 3 chairs to make. If the price was higher than that, they would be getting poorer to spend that. It's cheaper for them to do it themselves. So we know the ceiling on the price of a shirt has to be 3 chairs. So the price of a shirt has to fall between 2 chairs and 3 chairs. Anything in that range is acceptable. 2.1, 2 1/4, 2 1/3. That math is going to be a nuisance, so I'm going to keep it real simple. We're going to conclude, and by the way, there are obviously multiple options here, but an acceptable term of trade is between these countries, 1 shirt will be exchanged for 2.5 chairs. Will Heldia be making a profit on every shirt they sell? Yes. Will Romanotin be saving money on every shirt they purchase? Yes. Both sides are going to win. This is a mutually beneficial term of trade. Now we need to apply this to the quantities that we had from specialization. We'll do this in a different color to make it stand out. Even though I'm running out of board rapidly, I think we can still fit this in. So our net trade, I don't know what shape that is, but it's going to work because, like I said, live show. Recorded, rebroadcast. One take. How many of these shirts does Heldia want to sell? What do you guys think? I think they're going to sell 20 shirts. How's that sound? 20 shirts? So what is 20 shirts equal to in this ratio? 20 times 2.5, last time I checked, is 50 chairs. So Heldia is going to sell 20 of their shirts, which is going to leave them with 30 shirts. Romanotin will be buying those 20 shirts, so they're going to get 20 shirts. Romanotin is then going to give Heldia 50 of their chairs. So Heldia will end up with 30 shirts and 50 chairs, and Romanotin will have to sell 50 of their chairs, leaving them with 70 chairs. This is the simple flow of how Heldia and Romanotin can identify comparative advantage and then specialize in trade. What this doesn't show us is how they benefit. And I'm going to use the bottom half of the board, and while this is suboptimal, I'm going to do it anyway. Let's do a little quick graph so we can graphically see the best we can what just happened. We're going to put shirts. Actually, I'm going to put chairs over there. Chairs here. Shirts over there. We look at, we're going to make Romanotin blue. We're going to have Heldia be brown to help delineate the two. We'll identify our values in red here. So our max chairs are 100 and 120. So we'll go 50, 100, 120. So here's 120, here's 100, here's 50, just as a reference point on the axis. And then our shirts go to 50. So we'll do 25, 50, and we'll put 40 right there. Now we can show what the trade-offs look like in graphic form of production possibilities given the constraints of these two countries. And Heldia goes from 100 chairs to 50 shirts. We'll put it in brown. And I'll label it Heldia. And then we have Romanotin in blue, which is going to go from 120 chairs to 40 shirts. There we go. Now let's plot the coordinate points of our net trade to see a visual representation of how each country, after comparative advantage in trade, will be consuming beyond their production possibilities frontiers, which in an autarky would be unattainable. We end up with Heldia, which we're going to plot as point H, at 30 shirts, which we'll put here, 30, and 50, we'll dot out. Point H, beyond its ability to produce on its own. And for Romanotin, we will take 20 shirts, which we will put here, and 70 chairs, dot out. Boom, beyond its PPF. As we can see here, by maximizing the efficiency of each country's separate ability to produce with less sacrifice, we become more efficient collaboratively, and the outcome of the collaborative endeavor of a commitment to efficiency is that there is more for everyone on both sides of the transaction, and you end up wealthier than you did by yourself.